creativity in art is huge. You can't do art without being creative. And in science, it's very much a similar thing. Um, there's so much that's not understood in science. I mean, that's why we do so much research, especially in medical research. Um, there's so much that's not understood that you have to be creative. You have to be, I mean, not overly abstract, but you have to be able to visualize something, and then in order to come up with an idea, an explanation of why something happens, and then be creative again to develop some sort of experiment to test this, and then you kind of diminish your creativity when it comes to data analysis because you don't want to be overly subjective, and but so it's kind of a fine balance between having that kind of artistic creativity and then being very technical and objective at the same time. But it's definitely, I think if there's a connection between science and art, that would definitely be it, just in terms of creativity. I've always been fascinated with how the heart works. I remember as a little kid, there was, for some reason, some sort of article in the Toronto Star, it's the regular newspaper, about the heart, and I just really liked it. They had diagrams and stuff, and I'm not sure what exactly about it. I can't really remember what about it actually fascinated me at first, but I ended up doing my grade 6 science project just as a research type project, just looking at the heart and how it works, how it functions as a pump. Well, there are different types of cells in the heart. I guess the main cell is called a cardiomyocyte, so a heart muscle cell. It's different from other cells in the body. Well, first of all, being a muscle cell, it means that it contracts. Mm-hmm. So it generates a certain force every time it contracts. What's really cool about the heart is that it doesn't need input from the brain or from any other organ to actually function. You could totally take a heart out of an animal and it'll still be beaten on its own completely, and as long as it's getting whatever nutrients it needs, it can continue to function totally on its own. If you actually have it hooked up to whether it's being fed nutrients or in a bath where there are nutrients and it's right temperature and everything, this heart can beat almost indefinitely. I think it's really only been tested for a number of days, but no one really knows how long it can go on for. So that I think is really cool. Another thing is, most people know the heart as being the organ that pumps blood. So not very many people know that it does actually secrete hormones. It does have a signaling function in that sense, or an endocrine function, what we call it. And I think it's pretty cool also that there is actual electrical conduction through ion currents within the heart, how it works. So those are all kind of things that I kind of learned along the way, and I was like, wow, that's really cool. The first time I saw what a real heart looks like, I was like, there's nothing to do with this little Valentine heart kind of thing. But yeah, after studying the heart for a little while, you kind of realize that, okay, well, the heart's made of 4 chambers, really. You have the atria and then the ventricles. And I guess kind of the atria, you could sort of think of them, they're slightly more rounded. The ventricles are larger, and they appear to be a little bit more elongated. They're also a lot more muscular in the heart. So in the ventricles, a little bit more muscular, and they kind of come down to an apex. So it's the heart kind of sits in the body on an angle, and so it kind of comes down like that, I guess. So yeah, like if you if you take the Valentine heart and you skew it slightly so that the right side is a little bit smaller and the left side a little bit bigger, and then you kind of shift it on its side a little bit, it actually very much does resemble what a real life heart looks like. Of course, the Valentine heart is also a little bit more rounded. They puff out the top part, but if you like, squeeze it down a little bit and just elongate the whole thing a little bit, it's actually it's pretty similar. So it actually does have some sort of basis, some sort of relation. I thought that was really cool when I suddenly realized it. Yeah. I never really put the emotional feeling of love with I guess, the science of studying the heart. That's really great, something to think about. However, now that kind of bringing this up, certainly, at times when I'm sad or I get hurt, I'll say my heart hurts, and I really there's a pain right there. But yeah, I guess I didn't really put the two together as a connection. And that'd be a really interesting study to see, when someone is emotionally hurting, why is it that, deep down in their core, where their heart is, why is it hurt there? What are the I guess, signals that kind of relate the brain to that area? Who knows? That's kind of might be a cool thing to investigate. I don't know. It's really hard though sometimes to investigate, feelings and relate that back to, the scientific signaling and, what's going on. But then a lot of things in science is difficult to investigate, so yeah. But never really thought of it in that way. Science is very technical in the sense that, if you're going to make a statement about something, you have to have evidence. There's always has to be data and evidence backing up what your ideas or what you're trying to say. I guess typically on a Valentine's morning, I'll wake up and just think about, okay, who do I love? I'm like, oh, I love my cousin in Toronto. I'll email them. I love my friend in Jamaica. I'll send a little email there. You have to be objective, and emotions are quite the opposite, right? They're very subjective, and I guess most scientists are, they tend to step away from the subjective just because this is what we're trained to do, and this is what we have to do.